We woke up to this morning, so you can see that the temperature is supposed to cool at like 77, and it's not. The one upstairs is working, so at least we have that. It's about 94 degrees outside right now, and clearly there's a problem. These are newer AC units. They're not that old. They were under warranty, but the easiest way to do this is just to fix it yourself. And let me show you how that's done. First thing, check your breakers. There's a couple things you need to know. These are double, so this is basically, if you look at your house, there's AC that comes in two phases. So basically you have a leg for 110 and another leg for 110. And when you tie them together like this, this is where you get your 208. So I have one for each of them. And then the other thing to keep in mind is there is typically another breaker that runs the hair handling units up in the attic or wherever you have them. So if that was the case, then the display on the thermostat that I just showed you wouldn't have power, so that's not tripped. If it was flat off, I would go and look for another tripped breaker in here. I'm out looking at the units themselves. So this is the one I repaired last time, and now this is the one for downstairs, the one that's not working, and it's basically just kind of dead. We have disconnects, and the disconnects are nothing more than an electrical connector where I'm gonna pull this out. And basically it just has for each of these, it's not a fuse, it's just basically a piece of copper. Now, I've had problems where these things aren't seated properly, they get hot and they melt, and that is not the case. If I wanted to, I could measure voltage, but realistically, I don't think there's gonna be a problem here. More than likely, it's gonna be the capacitor. So, without having a bunch of knowledge on these, the very first thing you're gonna do is you're gonna have to test these. Now, before I pull the cover off, I most certainly am gonna disconnect this and make sure there's no power. It's like 94 degrees, but the bottom line is there's a bolt here and a bolt here, and then this will pop off. Again, there's 208 in here, so you could very easily hurt yourself, maybe even get yourself killed if you don't disconnect this. But all the components for that are in here. If you look at it, primarily there's just a motor for the fan, and then in underneath is the compressor. And then the rest of it's basically just cooling fins and stuff. So I think you can see inside there that aluminum, like a fin, like a radiator. So everything's inside of here, at least for this portion of it. There is a relay that people usually just push to see if it'll spin and whatnot. But the bottom line is usually something trips. And also usually there's an alarm code in here. So I'm gonna pop this cover off and see what's what. So this is where an alarm code would show up. And as you can see, this thing is just flat dead. So there might be something a little bit more of an issue. Now, if I was gonna test this right now, that black and that red wire, that is 208 coming into it, and the green one is ground. So this disconnect, that's where those are. So realistically, I should see if it's even got power, and that is done with a voltmeter. So I got my voltmeter set to AC, and I have 0 volts going to it. So it's dead because I don't have any power going to it. And I suppose there's the disconnect. That didn't seem to be tripped, but on the same note, there's no power to it. So I'm gonna stop with what I'm doing here, and I'm gonna go back to the load center and check the breaker. So I'm touching these, and that one, it was here, but it feels like it tripped. Now, here's the deal. I still want to test that capacitor, and the reason being is these usually trip for a reason, and it's usually the capacitor's fried. So we're going to test that capacitor before I do this. Now, I could have just reset the breaker, but I'm pretty sure that it tripped for a reason, right? So before we do that, we want to make our checks. And in order to do that, I don't want any type of voltage in here, right? Now, I know it's turned off at the breaker, but suppose, God forbid, somebody turned it off. So this disconnect is to make sure that there's no possibility of me getting electrocuted. And the other thing is I'm going to take another voltage check right here and make sure that this isn't a problem. After that happens, I'm going to go look at this capacitor. This is a dual capacitor. It's wired a little bit differently. There's a run capacitor and a starting capacitor, and they serve different functions, but that's all you need to know. If these are being tested, I just need to pull them apart, or out of the system so I can access those leads up on the top, and then make sure that there's not a problem with this and they've got to be put back in the same place. But I'm going to order another one of these capacitors if this one's failed, and that is probably going to take care of our issue. So the only thing I did was take out that one screw right in here, and now it's just dangling. Now you can see there's a common wire, which is this one, and then there's the other ones. Now keep in mind, if this thing is charged, it still has voltage in it, and you could hurt yourself just by touching these. So one of the things that people typically do is they'll grab a piece of metal or something like that, and they will put it across here and they'll discharge it that way. The problem is it discharges super quickly. So it'll basically create an arc. That's not what we want to do. The easiest way to do this is just grab your voltmeter and put it across it, and you will watch it drain potentially through the voltmeter. So that's what we're going to do first, make sure this is drained, and then I'm going to measure the capacitance. Again, normally somebody will just grab a piece of metal and arc this, but there's no resistance. That means that anything that's in here happens immediately, and there's potential for an arc flash. Don't do that. All right, so I have my voltmeter, and what I want to do is make sure that there's no voltage in here, and there's no voltage there or to here, and no voltage to here. So this is safe. So if I were to grab a piece of metal and short these out, I'm not going to get an arc flash if I were to touch these together. The one with all of the wires is the common, and this one, it says Herm, and I can't remember what that stands for, but the other one says fan. So the brown one is fan. I could take all the ones off the common, but that doesn't make any sense. I'm going to disconnect this one and disconnect this one, and you have to have a meter that has a symbol on it like this. That's a capacitor, and or the symbol for a capacitor. I'm going to record this with a picture so I can review it. The other thing that I want to do, record this value, this 40 plus 5, and then also it wouldn't hurt to have this information right here, which is the rating for everything in here. All right, so let's take a look at this. So I put in the part number, right? And that is what I got directly off of the unit itself. And I look at this and it says, supply house, and I click on this. This is the right one, 4 ton, 16 SEER. But then I go through and I start looking at the parts. If I needed any of this stuff, hit load more. And look at that, 535 microfarad. 440 volts, dual round capacitor. Well, here's the deal. I already replaced one of these, and I knew it was a 535. The group that basically is doing this beforehand said he had one in his truck. He put in the wrong value. So I'm not so happy about that. They're rated at that rating for a reason. Will they run? Yeah, they'll run, but that's not the right one. So I can order it through here for $46, $47, or I can just do what I did beforehand, which is go through and get it from Amazon tomorrow for 20 bucks. Now that I've gone through and I've verified it, one, I found a problem. I found the problem that they put in the wrong size capacitor, probably because that's the one that they had in the truck, and they didn't have the right one. So he put it in without telling me, because these guys are dirtbags as far as I'm concerned. And anyways, instead of just getting them involved, I think what I'm going to do is I'm just going to order this and put it in, and then it probably will take care of the issue. So that's where I'm going to start. So here's another funny thing. I noticed when I pull it apart, they use this, but this is like literally just down in the floor. Look at this, it's been here forever. This is used for holding that capacitor in place. So apparently they felt that it wasn't necessary anymore or something. Yeah, that's ridiculous. Anyways, here's the other thing that could be an issue. There still could be an issue with the breaker itself. And I don't want to apply power to this. So what I do is I would basically look inside of here, and I use my voltmeter to make sure that the breaker's not fried. Now it's disconnected, so if I turn it back on, this is not going to kick back on. I think in the interim, I'm just going to go ahead and connect this again. There could be 208 on it. You're touching this with bare fingers. You could electrocute yourself, potentially. But I just want to kind of put it back to a POR state, which is a process of record, which basically means put it back the way that you found it. All right, so anyways, I have it this way. Again, it's disconnected. I'm going to go and test the voltage and make sure that the issue is not with the breaker. So clearly it was tripped, but this breaker is probably 20 years old, right? So, and it doesn't get kicked on and off very often. So I'm gonna turn this on, and it's not tripped or anything. Neither is this one. This one's running. I saw the minimum rating for the actual unit is 26 amps. So this is big enough, so they didn't have to. I still think that they should have run the larger one, but maybe the cabling's too small. Also, this really should say downstairs, and this one should say upstairs, and they don't. I also might want to put on here, this is the right handler and this is the left handler. But at this point, I want to make sure that this breaker is good, so we're going to go and take a voltage measurement at the disconnect. When you go to test the AC voltage on your disconnect, come on in closer. There's basically 4 contacts, and that's what these are. The power that's coming from the breaker are these 2 in the center, and then these basically, this is just a copper plate, if you will. So when we push this in, it allows the power to go from one side and then to the actual AC unit, from this side to the AC unit. So you only want to measure the 2 that are closest to the center, and there's my 244 volts. Now you'd think it's like, oh, it's AC 110 or whatever. It really just depends on your provider, where you live. There's different, you know, some of the places use 50 hertz versus 60 hertz, like in Europe. But anyways, the bottom line, it needs to be over 200 volts. And it's always a good idea to grab all your parts, little screws and everything that's going to get lost, and put them in a Ziploc bag or something like that. Okay, so this should be our new capacitor. Anyways, we're going to go ahead and pull this apart and reinstall it, and hopefully it won't take very long. Show you how to test these. So this is the new one, 35 to 5 microfarad. Just going to open the box. Physically, the dimensions should be the same, right? I'm looking at it, everything looks good. This one is the common. There's one for the fan. The other one says Herm. See, it's for common. This is a special type of meter that measures capacitance. A lot of the meters don't have this. So I'm going to make sure that this is zeroed. Anyways, at which point I'm going to go and measure the fan. And we're at 5.2 microfarad, and this one should be somewhere around 35. So 36. The problem with these is they have a tendency to go bad, and sometimes when they're cold, you don't see them go bad, and then you heat them up. There's special test equipment that goes along with this. 9 times out of 10, this is what happens with it, especially on a newer unit. These go bad. Especially the one that they replaced this one with is the wrong value. I'm not super happy about that. So I'm going to put this one in, and then we'll power back on and see if there's any other problems with that AC unit. All right, so I got my new capacitor in the old one. First thing I want to do is make sure that there's no possibility of me getting electrocuted. So I've already got this pulled out. That's live on the inside. I wouldn't want to stick my fingers in there. And then, of course, just to double check, I want to make sure that there's no voltage across the capacitor before I pull it out. I can also check on the leads where it's applied in, and there's nothing. So this is pretty close to the same size. Slight difference. Again, this is not the right one. They put it in there and it's not the right one. So basically goes like this, and I'm just going to grab a hold of these and start migrating them over from one side to the other. Some of these are better than others, for sure. one is for condenser, and this one is for the fan. Okay, so they're all in. This one's now worthless. The only thing I need to do is basically just reattach this. And this is the one that was on the ground. I'm not sure if it's the right one. I think it's the right one. I think that they dropped it and we just had another one that just put in place. So, actually, this needs to go this way. Alright, so I'm just gonna try and get this started. It's just sheet metal. These are just sheet metal screws. It's not exactly a precision setup. Get it started by hand. Make sure that nothing's touching or shorting out. So that my clutch set it nice and light. Okay, so I don't want this resting on the board or anything like that, so I'm going to lift it up a little bit. And also I don't want, this is, there's a metal frame. We don't want this shorting out. So everything looks good here. So that's kind of it. Now, at this point, I primarily just want to grab my disconnect. All right, so now we're plugged in. And if you look at it, now we've got some life to it. Now, there's ways where people grab a contactor. I'm not seeing any alarms on it where it says on, but you can force these. I'm not gonna do that. We're just gonna run it through its paces. And I'm gonna double check the values on this. Again, they use the wrong value, so I'd replace this no matter what. But at which point, we're just gonna button this cover back up and make sure that this thing is running. Okay, before we get too far into this, I do have a C3 alarm, and I'd have to look at to see what that actually is. So we're gonna look at that. Okay, so I power cycled the air handler, and now it's at C1. I don't know what those codes mean. So I'd have to do some research, because the bottom line is, I think when they put these in, they figure that the customer doesn't know what they're doing, so they just don't even bother to give you the documentation. They probably throw it in the garbage, actually. It's kind of ridiculous. But anyways, as you can see, the fan is blowing, and it's hot, so that's a good sign. This wasn't working before. The bottom line is, I'll go ahead and I'll double check that capacitor, but that circuit breaker tripped. It could be an issue with the circuit breaker, but usually it's the capacitor. So at which point, I'm just gonna put this cover back on and call it good. So I'm looking at this and I'm going to measure it, and it's kind of a mixed result. So I go to measure it here, and then I hit 1, 2, 3. So I got my 5 right there, microamps, or excuse me, microfarad. And then I go to this one, and it's reading 40, but it's taken a while to get there. See, it's 2.9, and it's holding there. And then it goes to 40. There's something up with this capacitor. So there's some bunch of stuff going on the inside. The bottom line is, I replaced it for 2 reasons. 1, it's the wrong value. And then 2, it's behaving oddly. So we just replaced it. It was a $20 fix, and realistically, I spent more time filming and explaining what I was doing than it would have taken to do. This really, if I would have had one in hand, I could have fixed that AC unit in probably about 10 minutes.